Hi everyone, this particular video is targeted towards providing more clarity on the sets through some practical examples. It is going to be a beneficial video for the students of class 11th because a lot of questions are mapping to their course. Also, it is going to be beneficial for the people who want to have a deep understanding of the set. At times, the student get confused in that which particular collection is a set, which particular collection is not a set. So this particular example is going to take them through that. Now, when you want to solve this kind of example where a collection is giving to you and you have been asked whether this collection is a set or not, what is the essential thing you need to keep in mind? You need to keep in mind the definition of sets. And how the definition of sets actually states a well-defined collection of distinct objects is a set. This is the most important word, a well-defined collection. This is the most important word which is going to solve all these 9 statements. Keep this thing in mind, well-defined collection. So like first statement says the collection of all months of a year beginning with the letter J. Doesn't matter, I means everybody can answer that. What are the months starting from letter J? It is January, not February, not March, not April, not May, it's June, and then it's July. So these are the 3 months which are starting from the letter J. It doesn't matter who collects this particular who collect these particular members. Everybody is going to come up with these 3 elements. This is very important. Doesn't matter who collects. Either I am writing these names or you are writing these names. Our collection is going to be same. January, June, and July. So 3 different months which are starting, and this particular collection is very well defined. That means doesn't matter who collects the members of this set. They are going to be same. So that becomes a set. And I'm to put a right tick. That means yes, this statement or this collection represents a set. Second, the collection of 10 most talented writers of India. I am not sure. Maybe I am, I like Munshi Premchand, so I will write Munshi Premchand in this particular set. And probably I like, let's say, Millennium books. So I probably would put Millennium books here. But somebody else has some different opinion over 10 most talented writers. So there is a variation. So this is not a very well defined statement. Most talented can vary from thought process of person to person. So in that case, it doesn't become a set. So it is not a set. Now I think there is a lot of clarity. That means the elements are supposed to be so well defined that doesn't matter who collects the elements or members, the collection is supposed to be same. The team of 11 best cricket batsmen of the world. I may find Sachin Tendulkar or Rahul Dravid or probably Greg Chappell and all these batsmen are in the best collection, while somebody else will disagree and they say, okay, these are not the members of my collection. So in that case, again, there is a variation, and this is again not a set because the term best cricket batsman is not well defined. The collection of all boys in your class, it is definitely going to be a set because it is very well defined. Boys in your class, so it doesn't matter who counts it. The number of boys are going to come out to be same. So it is a set. The collection of all natural numbers less than 100. So x, if I see this, what are the natural numbers? So if I start writing this collection, it is 1, 2, 3 up to 99. So very well defined. Again, it becomes a set. The collection of novels written by Munshi Premchand, definitely a set because it is very well defined. In this collection, all the novels written by Munshi Premchand are going to come up. The collection of all even integers, we are pretty much sure it is going to be +1, +2, and so on. So it is going to be a set, pretty much defined. The collection of questions in this chapter, we are pretty much sure if there are 10 questions in the chapter or 20 questions in this chapter, it is a very well defined statement. So this collection becomes a set. The collection of most dangerous elements of the world, and all of you will reach to a conclusion this is not a set because it can vary from person to person. For me, some animals may be dangerous. For someone else, the elements may not be dangerous. So what I am saying is this is the main focus to solve this question, that what is a well-defined collection. Let's move to the next question, that if A is 1, 2, 3, 4, 5, 6, insert the appropriate symbol. This means belongs to, and this means doesn't belong to. That means if the particular member written here is a member of this particular element written here is a member of this collection, then we'll put belongs to. That means within this, otherwise not belongs. So if you see 5 is there here, so we can simply put belongs to. 8, it is nowhere, it is outside actually, so it doesn't belong to. 0, I think you can clearly see 0 is below this, outside this, so it doesn't belong to. 4, I can see 4 is right here, sitting right here, so belongs to. 2, if I see 2, it is sitting again right here, and I'll again write it belongs to. 10, if I see, it is way outside the particular collection, so it doesn't belong to this set. Let's go to the next particular thing. I have discussed in my previous videos two different forms of sets, set builder form and roster form. Set builder form means the representing of the entire set through one single variable. So there is a collection of numbers, members are given 3, 6, 9, 12, and I want to put it in the set builder form. That means, so if I see how exactly the things are moving here, so you can see this, the important thing is to crack the code. So it is actually 1 into 3, the 3 is written this way, 6 can be written 2 into 3 simply, 9 can be written 3 into 3, 12 is actually can be written as 4 into 3. So what is happening? 1, 2, 3, 4. Natural numbers are moving and the 3 is coming against it. Or specifically, I can write it this way: 3 times 1, 3 times 2, 3 times 3, and 3 times 4. That means natural numbers are getting multiplied by 3. So if I am representing natural numbers by a small letter n, which we generally do, so x is going to represent member of this set. What is the nature of x? Nature of x is 3 multiplied with natural number. Look at this. Natural number is 1, 2, 3, 4 multiplied with 3 every single time. And we can specify it such that n belongs to n. That means n is a natural number and n is less than or equal to 4, because the last number in the set is 4. Last natural number is 4. So this is a roster form, set builder form of, and this is the tabular or roster form. So this is tabular or roster, and this is set builder. Second question, second set builder form, once again 2, 4, 8, 16, 32. I think everybody can easily see it. It can be written as 2 into 2, 2 into 1, sorry, the first element 2 can be written like this. 4, if you see, can be written 2 into 2. 8 can be written 2 into 2 into 2. 16, on the other hand, can be written 2 times 2 times 2 times 2. And 32 can be written 2, 2, 2, 2, and 2. So what is it? It is simply 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, and 2 raised to the power 5. That's how the movement is happening. 1, 2, 3, 4, 5. So this is a movement with respect to natural number. So I think now it is very easy. Once you crack the code, x such that x is equal to 2 raised to the power n. N is a natural number. It is moving like 1, 2, 3, 4, and so on. And n is less than equal to 5. That's the solution when we are putting it in the set builder form. Let's see the third one. And I think this is the easiest because it is simply as the previous example. So you can see it is 1 into 5, right? You can see that, or you can simply say 5 into 1. Then it is exactly coming 5 into 5. So you can simply put it 5 only. 5 into 5, 5 into 5 into 5. And then you can simply see that 5 times 5 times 5 times 5. So it is how it is happening: 5 raised to the power 1, 5 raised to the power 2, 5 raised to the power 3, 5 raised to the power 4. You can simply see that. So how would you write it? X such that x is equal to 5 raised to the power n, such that n belongs to n, n is a natural number, and n is less than equal to 4. So this is the confusing part where students do a mistake. This n is power. So power is going up to 4. You see, I've done a previous, no mistakes, fair enough. Then it comes 2, 4, 6, and so on. That means this is not stopping, this is going up to infinity. So I hope you can see these are the simply even numbers. 2 is an even number, 4 is an even number, 6 is an even number. So you can simply write that x such that x is an even number. It is one of the simplest. Let's see another example. 1, 4, 900 and so on up to 100. That means stopping at 100. Largest number is 100. So you can simply see what is it. First natural number is square. 4 is second natural number is square. 9 is third natural number is square. And if you see 100, it is 10 square. So what is happening? I think it is very easy to write now. It can be x such that x is equal to n square. Natural number is square. N is a natural number and n is less than equal to 10. So that's it for this video. We can see that set builder forms. Don't get confused in any of the concepts. You can easily pause the video wherever you want and you can go through it again. Thank you very much.